Hey all, we're talking about scalar multiplication of vectors. I don't think this is as difficult of a concept as sometimes. So there aren't any notes. I'm just going to kind of work my way through this assignment, do all the odds, so you have the answer key for the odds. But yeah, like I said, I think you'll catch on pretty quick. It's not the most difficult concept that we've ever done. So a scalar, you'll recall from when we did matrices, is a number multiplied into a matrix or a vector. In this case, we're going to do vectors. Matrices and vectors have some overlap, so that's what a scalar is. So in this case, you'll notice we have our number 3 attached to a vector u, which is this vector right here. It starts at the origin and it goes like here. So basically what we're going to do is we're going to multiply this vector right here. I'm just kind of going over it again. And we're going to make it 3 times as long as it was. So in this case, we went over 1, up 3. For u, for 3u, we would have to go triple this length. So we're just basically going to triple these numbers. So it's going to go over 3 and up 9. We go ahead, we can just draw that in. We add the little arrow right there at the end of it. And there is our new vector. Now, for number 3, you'll notice we have a negative scalar. Keep in mind, kind of like what we had to do yesterday when we subtracted vectors, the negative is going to take the vector and switch its direction. So in this case, we have a vector. There's the initial point. The terminal point is right there. We can go ahead and count it. We go over 3, up 3 for that vector. We're going to take the vector, keep the initial point, and we're going to just basically quadruple its length while also sending it in the exact opposite direction. So basically, we're going to keep the slope, but it goes the other way. So we're going to go down 12 and over 12. And go ahead and draw in our new vector the other way. So that was 12 and 12. I hope I counted that right. I'm pretty sure I did. So basically, I took these numbers here, 3 and 3, multiplied them by 4, and sent it in the exact opposite direction. So that's what we do when we have the graphed vectors. When we have a vector in component form, it's even more simple. So for example, here at number 5, we have negative 10v. V is this vector right here in component form, negative 1 and 6. We simply take negative 10 and multiply it to both of those numbers. So I'm just going to write that out. So it's going to be negative 10 times our vector in component form, negative 1, comma, 6, comma. So our answer here will just simply be, it's almost like distribution, negative 10 times negative 1, that will become 10, positive. And negative 10 times 6 will become negative 60. We leave that in component form, and there's our answer. For number 7, you'll see that we have an addition sign in the middle. That's kind of the most typical way that you see scalar vectors, as they show up in an addition or subtraction problem. So basically, you just multiply in the scalars before you do the addition. Please do that in that order. Order of operations matter. So I'm just going to write it out. It's going to be negative 2v, and v is going to be negative 1, comma 6, plus 5u, in this case u is 3 and 4. By the way, this kind of multiplication with the vector next to it, that's not the nicest notation. That's not how you're supposed to write these things. Normally you would just kind of multiply the number in. I'm only writing it for emphasis point. To kind of explain what we're doing. So I'm just going to go ahead and multiply that through. So that will become 2, 12, plus 15, 20. Oops, that was a bad one. I'm going to try again. So we add those two numbers together. We add the x components, 2 plus 15, that will become 17. 12 plus 20, that will become 32. And there's our answer. Moving on to number 9, we have negative 3u minus 4w. So let's just go ahead and write that out in the bad notation. Negative 3 times 3, 4 minus 4 negative 2, 8. So the first one is just going to become negative 9, negative 12 in our brackets. And with this minus sign, I have two options. I could either leave it minus and just multiply in the 4, or turn it into a plus and multiply in the negative 4. That's what I'm going to do in this particular case. So that's going to become plus negative 4 times negative 2 is 8. Negative 4 times 8 is going to be negative 32. That's a bad 2. I'm going to try again. We add those together. We're going to end up with negative 1, comma, negative 44. I just simply added the x components and the y components. Now we need to find the magnitude of our vectors. I'm going to start with number 11. We have negative 3v. Notice we have switched up the vectors. We're not using the ones for 4 through 9. We're using these new vectors right here. V is going to be 3 comma negative 2. So I'm going to write it with kind of the not the crunchy notation. Negative 3 times 3, negative 2 for emphasis. And then we multiply that through. We're going to end up with negative 9 comma 6. And we want to find the magnitude of this vector. So to do that, we just have to use the Pythagorean theorem. A squared plus b squared is equal to c squared, where a is going to be negative 9 plus 6 squared to get c squared. That will be 81 plus 36 is equal to c squared. And we get the square root of 117. I skipped a step there. I just added 81 plus 36 to get 117. Now you'll notice here it says round to the nearest hundredth. So at this point, you should grab a calculator and figure out what number that would be. So the square root of 117, I'm currently typing it into the calculator as I talk, will be 3 radical 13. That might be how your calculator spits out that answer. So if you need to get the decimal thing, you're going to hit the button second, it's the light blue button. And then it's the button, it looks like this. It has the little arrows on it and the wavy little line like that. And that should give you your answer. I lied to you. I just checked it with the calculator. You don't have to hit the second button. It's just that button right there. It will give you the number. In this case, it's going to be 10.82, rounding to the nearest hundredth. Okay? I didn't feel like that was right. So just to clarify, if you need to get the decimal, you type it into your calculator, then hit the button. It's right above the enter sign. It's got the little 2 arrows on it or the wavy 2 wavy lines. That'll do it for you. All right, so let's go to 13. We have 3v plus 4w. That's going to be 3 times 3, negative 2, minus 4u, which is 4, 1. So that'll be 9, negative 6, minus, I'm going to do it the other way than I did on number 9 this time, just for variety. 16, 4. That'll give us 9 minus 16 is negative 7. Negative 6 minus 4 is going to be negative 10. From here, we need to figure out our magnitude. So that'll be negative 7 squared plus negative 10 squared is equal to c squared. That'll be 49 plus 100 is equal to c squared. And c is going to be the square root of 149. Once again, I skipped the step where I added 49 and 100, and then just took the square root of that. So we type that into our calculator. It's going to be about 12 something. And we get 12.21. Rounded to the nearest hundredth. Number 15, let's just keep going. 6v plus 2w is going to be 6 times 3, negative 2, plus 2, negative 3, comma 6. That'll be 18, negative 12, plus 6, negative 6, 12. Now, technically, this is where you should start, because this isn't the best notation, the first line here. That's not really how you write those things. But I'm writing it just for the emphasis point because I'm not in front of your face. So then we're going to get negative 12, 0. And I am going to skip the Pythagorean theorem for this because we have a 0. I know that the magnitude of this is just going to be 12. It's going to be 12 units long. If you really need to prove it to yourself, it's going to be 12 squared plus 0 squared is equal to c squared. If you do the math on that, you'll end up with 12. So now I'm going to just go ahead and flip over to the back. Because the back, these questions are just slightly stranger, so I just want to make sure that you understand what they're actually asking for. Compared to the original vector v, or w, describe the magnitude and the direction of the result. No calculations are required. So we have vector w here. We need to describe half of w and negative 5w. So I'm going to start with half of w. Compared to w, half of w would be half the magnitude but the same direction. If we drew the picture, it looks something like this. Say w went like that. Half of w would just be half the length, but the same direction. Let's go ahead and talk about negative 5w. So if this is w, negative 5w would go the exact opposite direction, but be 5 times as long. I know that line isn't actually 5 times as long as the line I just drew, but for emphasis point, I think it demonstrates what we needed to show. So I wrote as long in this case. I probably should have said, instead of as long, magnitude. But regardless, we have the same kind of idea. All right, 27. We have negative 3v compared to this vector. It wants it in standard position. We haven't talked about standard position. Basically what that means is it just starts at the origin. So in this case, our vector goes over to, up to, in kind of this negative direction. It looks like a negative slope. So if we're taking this and going the exact opposite direction, but starting at the origin, I think our vector has to be 3 times as long in the opposite direction. So we're going to start at the origin and go out to 6, just like that. So we went down 6, over 6. in the exact opposite direction that the vector was initially pointing, okay? All right. These are very similar to the ones that we did on the front, so I'm not going to spend a lot of time doing them. I'm just going to write my way through them. 5y, I'm just going to skip straight ahead. That's going to be -10, -50. And half y plus 4x is going to be -1, -5. Notice I'm not writing out like that first step anymore because it's technically bad math anyway. Plus, if you're confused on what you should do with them, you should just look at the beginning of the video when I explained how to do the ones in the front. They're very similar. So the answer for this will be 15, -1.